All right, let's finish up lesson 11. Um, remember we did a quadratic formula? So really the two subjects are not even close to the same thing. But that's all right. Remember we had a big talk about that the other day as far as why they do that. So let's just talk about the first part of this, which is circles. So let's put a circle on here. Just happen to have a circle here. All right, let's just talk quickly about a couple things. This little dot in the middle, we don't call that the middle of the circle. What do you think we call it? Any idea? It's not in the middle. It's just the center of the circle. That's all it is. Okay, nothing earth-shattering there. So that's the center of the circle. All right. What if I started from the center and I drew a line segment, yep, to the outside of the circle? Or what we say is this is on the circle. I said outside of the circle, but it's really not. It's on the circle. A lot of people think of a circle as like a flat disc, and like you're sitting on the circle right here. That's not on the circle. The circle is actually the line that goes around. You follow me? All right, so we have to, because I had a lot of people say that, yeah, but I'd be on the circle if I was here. It's not like a flat disc. It's just this line that goes around is really considered the circle. You okay with that? All right, so let's see. Yeah, this is the radius of the circle. And what do you think is next? What if I took this radius and I did what? Yeah, I stretched it. It still goes through the center, but it goes all the way from one end of the circle to the other. Like that. Okay, so I call that whole thing the what? The diameter. Good. Alright, that's pretty easy. Here's a couple things. I'll keep that there. Let's draw another circle. Here are a couple things, make it a little bit bigger, that you may not be quite as familiar with. All right, that most people are familiar with that. You learn that, I don't know when you learn it, I can't remember, middle school maybe, something like that, 6th grade, 7th grade math, I don't know, maybe even earlier. But this is the kind of stuff that they usually leave for high school geometry. So what if I went from here to here? Is that a radius? No, that's not a radius. A radius goes from the center to the circle. This connects 2 points on the circle. It doesn't have to go through the radius, or sorry, it doesn't have to go through the center, right? It just hits any 2 points on the circle. And we call that thing a chord. Did you ever hear that? You never heard of that? Did you take geometry? You took it here? Yeah? Alright, so, well, anyway, you may not remember it, but I bet you learned it at some point. Well, at least you were taught it. Apparently we didn't learn it, but you were taught it. So that's a chord. All right, it goes from one point to the other on the circle. You with me? So over here, there's something else that's a chord over here that we didn't really say it's a chord. What else is a chord over here? Is the radius a chord? The diameter is a chord, right? Because the diameter goes from one point on the circle to the other. This center is not on the circle at all, is it? All right, so the radius is not a chord, but the diameter would be a chord. It's just a chord that goes through the center of the circle. Right? A chord doesn't have to go through the center of the circle. It just has to hit 2 points on the circle. We good with that? All right. Let's do another word here. What if you had a line that actually, now a chord, let me say this. A chord is a line segment. All right? It starts and stops. So it starts on the circle and it stops on the circle. It doesn't keep on going through. This thing right here, if I put arrows, what is that? That's not a line segment. What is it? It's just a line. Right, it's just a line. All right, so it goes all the way through. We call that thing a secant. S-E-C-A-N-T. Secant. Ringing a bell at all? If chord didn't ring a bell, I doubt secant will ring a bell, all right, because you'd probably deal with chords a little bit more than you do secants. But anyway, that's a secant. We're learning it now for the first time. Even if you never heard it before, it doesn't matter. We're learning it right now. All right, everybody with me so far? That's pretty easy, isn't it? What's the secant? Secant's a line. It keeps on going, okay? It doesn't just start and stop, but it does go through the circle at 2 points. Hits a point here, and it hits a point right here. We good? All right, let's do another line. This line, I'll try to, boom, right there. Now, how many points on the circle does that line hit? Just one, right there, okay? It kind of like skims it, right? It just hits it at 1 point, and I call this a tangent. Well, me and everybody else in the geometry world, I guess. Not just me. All right, but we call this a tangent. So what is it? It's a line, right? And it hits the circle. How many points? Just at one point. So there's a little bit of a difference, isn't there, between a secant and a tangent. All right, and all right, that's good enough for that. Let's do another circle. Let's bring this over here. Make this a little bit bigger. So right now it's just vocab stuff. We're going to be doing some math in a second here, but we're just flying through these vocab words pretty quick here. Let's do this. What if I said I had a point, let's go in a different color, just so it stands out a little bit. What if I had a color, or a point right here, and then, we'll make that a little bit thicker, and then a point right here, alright? And what if I went along the circle? Now we've talked about this before. I'm not even going to write this down, but what is the distance around the whole circle? Circumference. Very good. Okay, and what we're going to talk about here is not the distance around the whole entire circle. We're just going to talk about the distance from one point on the circle to another. It doesn't have to go all the way around. So I'm going to try to draw this. It's kind of hard to follow along on this sketch pad thing. That's not too bad. All right, do you see that right there? We call this right here an arc. All right, so if I go around the circle, it's not a straight line, isn't it? It's following that circle. So it's going around the circle right here. If I just go from one point on the circle to another point on the circle, I call that whole thing an arc. Technically, if I started here and I went all the way around to here, okay, that's also an arc. It's just the arc is the whole entire circle, all right? But when we normally talk about an arc, it's not usually the whole circle. It's a part of the whole circle, right? It's a portion of the whole thing. We've done this before. Do you remember doing this? We found the distance from here to here, all right? And we're not doing this right now, but I'm just getting you to try to remember. Let's say you had a line here, You got two radii, right? And let's say, I don't know, that's 100 degrees. Do you know how to find the distance from here to here? Do you remember circumference is what? Circumference is 2 pi r, isn't it? Remember that? But if I wanted to find the distance around here, that would be of a whole entire circle. We're not doing a whole circle. How much of the circle are we doing? We're doing 100 degrees, right? 100 degrees out of what? The whole circle, which is 360. We did this year, didn't we? Yeah, that's what I thought. So what you would do to find the distance from here to here, you'd go 100 over 360, 2 pi r. Make sense? Or pi d, however you want to do it. All right, so if you knew the radius was 5, then you can plug all that stuff in, and you've got the distance from here to here. That's just a review. We're not really talking about that today, but we have talked about arcs, right? So it's not the first time that we've talked about an arc. I just wanted you to be aware of that. And let's get rid of that 100. There we go. Let's do this. If we have an arc that's less than 180 degrees, we call that a minor arc. It's less than 180 degrees. So basically, if I did this, if I took this line right here and stretched it out like to there, from here all the way to here would be how many degrees? 180, okay, because that's 180 degrees right there. So that would be 180 degrees. This arc just goes from here to here. That's less than 180, isn't it? It's less than halfway around. We call that a minor arc. So guess what? Let's do a different color. We'll go blue. We'll go light blue. Let's go a different color. What if I did this? What if I went from here? Now, I'll probably not be right on this arc, but I'm going to try to be careful. Oops. What if I went from there to there? Okay, from this point to this point. Look at that blue arc right there. What do you think I'll call that blue arc? Very good. Okay, if a minor arc is less than 180, look at this blue one. That's more than 180. We went more than halfway around, didn't we? All right, so I would call that a major arc. So a major arc, how would we say that? It'd be greater than, right? Let's say greater than. We could say more, that's fine, it's the same thing. But we'll say greater than 180 degrees. With me? All right. I'm not going to draw this in because there's too much going on here, but watch. What if I went from here and I went exactly 180 degrees? Any idea what you think that would be called? It's not a whole circle. A whole circle would be the whole way around. So it's not a whole circle. How much of the circle? It's half a circle, but what do you think we call it? Any idea? No. It's not going to use the word half. You've probably seen this before, but semicircle. You've heard of that before, haven't you? Yes? No? Maybe? Okay, it's a semicircle. So a semicircle, it's an arc, all right? So it's still an arc that's exactly equal to what? 180 degrees. You with me? All right, so a semicircle would be exactly 180 degrees. Minor arc is less than 180. A major arc is greater than 180. Okay, let's do this. Let's talk about this minor arc right here. Do you see this angle that's formed? I call this angle right here, I call it the central angle. I call it a central angle because where is the vertex of that angle? It's at the what of the circle? Center of the circle, right? So if the vertex of this angle right here is at the center of the circle, I call it a central angle. With me? Right? Come on now. So this is a central angle. Now, there's something that's true about a central angle. This angle right here, remember what I said before? Let's say make this 100 degrees. Remember I did that before? This is kind of a nice little thing. The central angle is exactly equal to the arc that angle cuts off. Do you see that angle comes and hits right here, and then the other part of the angle hits right here? We say it cuts off this arc. You get it? Yeah. All right, so this angle is going to equal this arc. So we measure arcs in degrees as well. Right? Like over here, I've talked about minor arc is less than what? 180 degrees. So an arc must be measured in degrees, right? Greater than 180, equal to 180 what? 180 what? Degrees. So arcs are measured in 180 degrees. So if I call this A and I call this B, we measure this minor arc just going from A to B. So I call this arc AB. Now, do I just put the word arc in front? No, I make it like this. I put a little arc symbol over top of it. See it? Just like lines and line segments have symbols, this thing has a symbol as well. That's an arc. So arc AB is equal to, now if the central angle is 100 degrees, what do we say? The arc that it cuts off is going to be the exact same degrees. So if this central angle is 100 degrees, what is arc AB? Give me the number. 180? Come on. Look, this is 100 degrees, so what's the arc going to be? It's going to be 100 degrees, okay? It's the same thing. It's exactly equal. Come on, let's get our minds rolling here. All right, let's think when I say some things and not just let it hit you and just bounce off. And I think that's what's happening sometimes, all right? Absorb it. So watch, this is 100 degrees. This arc is going to be the exact same thing, so it's going to be 100 degrees. So arc AB is 100 degrees, all right? Now watch. A minor arc, we can just use two letters to represent the arc. Because if I said arc AB, what do you think another way I could say arc AB? I could say, what else do you think? Arc BA, yeah. Arc BA, arc AB, same exact thing. It doesn't make any difference. But what if I put, let's put a point right here. Let's make that C, all right? And let's put a point, let's make this point right here and make that D, all right? So here's what I've got going on here. If I wanted to talk about this red arc right here, I would call it arc AB or arc BA. Make sense? What if I wanted to talk about the blue one? What if I wanted to represent what the... Okay, yeah, I don't just say arc BC, because if I just said arc BC, you could go from here to here, couldn't you? Is that the same thing as that blue arc? No. So I can't just call it arc BC. I would have to call it, say it, Ryan. BDC, good. I would have to call it BDC. So a major arc, how many points do you use for a major arc? 3. And how many points do you use for a minor arc? 2. Okay, what about a semicircle? What if I wanted to talk about from here just to D? If I called it BD, how do I know I'm not talking about this arc up top here? They're two different arcs, aren't they? They're the same measurement. They're both 180 degrees, but they're two separate arcs. So I would have to have another point. Let's talk about the top one. Let's not do the bottom one. Let's do the top one. What would I call the top one? BAD. I only use 3 points. I don't use this one. I could say BCD if I wanted to, right? It doesn't matter as long as I use this endpoint, and some point in between. All right, we'll move on to the next video.